What's up everyone, it's Mr. Lang, and in this video I'm going to teach you how to find the domain and range of a function from a graph. So let's get started. Alright, as you know, the domain of a function is all the possible x values. And when you hear domain, I want you to think left to right. Alright, now the range are all the possible y values. And in this case, I want you to think from down to up. So one kind of little thing that helps me remember the difference between domain and range, because sometimes it's easy to confuse them, is to write domain going left to right like that, and then range going down to up. Just a little thing. Sometimes people write that in the upper corner of their paper when they're doing stuff with domain and range. So what we're going to do is 4 examples, and for each example, you don't have to copy down the graph perfectly. Just make a nice sketch of it. You might need to pause the video in between each one, and then start it up again. So let's start with example 1. Example 1's a discrete function, and all that means is that it's got points kind of scattered along the graph. They're not connected by lines or curves or anything like that. So in this case, finding the domain and range is actually really easy. Remember, the domain is all the x values. So all we're going to do is look at the x values for each coordinate pair here. So I'm going to start with A, and A has an x value of 2. B has an x value of -4. C has an x value of 0. And D has an x value of 6. Now a lot of times you're going to see the domain kind of in these curly brackets. It really doesn't matter if you have them or not. Let me try that one again. Really doesn't matter if you have them or not, but if you see them, I just don't want you to be surprised by that. Alright, now the range is all the possible y values, so I'm just going to look at all the y values, which is 3, 1, -5, and 0. So the domain is all the possible x values. The range is all the possible y values. So a discrete function where you got all the points, very easy to do. Let's get to some trickier examples. Alright, example 2 is a linear function. It's a line. And the domain, again, all the possible x values. So what I like to do is take my pencil and go from left to right. And I can see when I hit the graph here, it's hitting here, but it's got an arrowhead here, so that means it's going infinitely down and to the left. Since it's going infinitely left, the smallest possible x value is -infinity. And we're going all the way, and it's pointing this way to the right. And again, it's going towards, up and to the right, but to the right's what's important here. It's going to go towards positive infinity in the x direction. So from -infinity to positive infinity. Now the way we can write that is using the and notation that we're familiar with. Is we go from -infinity in the x direction to positive infinity. So from -infinity to positive infinity for all x values. You can write it that way, or an easier way to do it is just to say all real numbers. Alright, so you can say it either way with the and notation or just by saying all real numbers. If it's ever -infinity to positive infinity, it's all real numbers. Now the range, since we already know how to find the max and min of a function, the range is actually really easy. The range is always the minimum to the maximum value, and we're talking about y values, so we're talking down to up. So for a linear function like this, the minimum, since it's pointing down, is going to be -infinity. And the maximum y value, since it's pointing up, is going to be positive infinity. So it's almost the exact same thing for the range. It's going to be -infinity to positive infinity, but in this case it's the y. So it's going to be -infinity to positive infinity. Or again, we can just say all real numbers. Either answer is fine. Alright, so linear functions, unless they're vertical or horizontal, these are going to be your answers. Alright, let's get to example 3. We got our friend here, the quadratic function or parabola. The domain, and as you can see here, we got the arrowheads here, and it's skewing a little bit left. That's what parabolas do. And although it's going up, it is going left. So when I take my pencil here and hit it, it's going to go towards negative infinity. And as I go forward here, it's going to go towards positive infinity in the x. So again, we can say either negative infinity to positive infinity, or we can just say all real numbers. Now the range is from the minimum value, y, to the maximum. Well, we know how to do that already. The minimum value is going to hit at a y value of -5, and the maximum value, since it points up, is going to be infinity. So the range is going to be from -5 to infinity. Now it includes -5, so it's going to be less than or equal to. That's going to be y, because we're talking about range. But whenever we have infinity, we use just strictly a less than or greater than, because you can never get to infinity, it can never equal it. So that would be our range. Alright, one more example. Example 4 is a square root function, and I don't have the graph here because I'm just going to draw it in. Alright. Square root functions always look something like this. I'll just do the basic square root function where it starts at 0, 0, and it kind of curves up and goes like this. That would be your basic square root function. Now the domain, all the possible x values, well, I'll take my pencil going this way, and I don't hit the graph until I get to an x value of 0. So the low point for the domain is 0, and I can keep going towards the right, and it's going to go towards infinity in the x direction. So we're going from 0 to infinity. So I can write that down. We're going from 0. We're going to include 0 because there is a filled in circle there. We're talking x because it's domain, and we're going towards infinity, which would be like this. So we're going 0 to infinity. Now the range is from the minimum value, and we're talking y, to the maximum. Well, the minimum value, as I make my way up here, is 0 for y. And with square root function, it's going up, and it's going up very slowly, but it is always going up. So we count that as infinity for the y as well. So the range is almost the same exact thing. It's 0 to infinity, but it's y, remember, we're talking about. Alright, so those are our 4 examples. Let's get to the SIA questions. Alright, there's 2 pages of SIA questions, 4 questions overall. And what I want you to do is find the domain and range for each. So you'll need to pause it here. So here's 1 and 2. And the next page is questions 3 and 4. So 4 questions total. Now listen, domain and range is a tricky topic, and it can be very confusing. I know when I first learned it, it was very confusing for me. So what would be helpful is maybe watch this video a couple times, see how you do on the SIA questions, and if you're having trouble, ask questions in class, or of course you can come see me during activity period. But thanks for listening, and I'll see you in class.